Okay, so after this necessary steps, you're gonna do some calculations. In this scenario, we will be doing the growth rate calculation. So growth calculation is defined as the increase of certain leaf areas across different conditions and etc. You could either use original data and smoothed data for calculation, but most cases I recommend to use the smooth data, which kind of will look much better and the biological makes sense. You could calculate the overall whole experiment, which means from the first day and all the way to the last day of the experiment. By calculating the growth rate, you'll be able to see what's the growth rate of each of the plants and what's the R square of these linear regression. You can also download this table easily. And you can observe if there's significant difference of the, of the growth rate across different experimental variables. You can check under, say, the same genotype across the different RaspiPheno. So here I want to say, I want to see the treatment and if we have any difference across the camera A and B, if there's any difference between RaspiPheno, etc. You can manually remove the data point along with very low R square values to clean up a little bit for your data. You can also download this plot directly to your local computer. Okay, so you can also do a stepwise manner by putting the growth rate for every few hours and calculate the growth rate. The smaller value you use is going to take a little bit longer to reflect the final calculation because of time, and I'm not going to go much of details, but you can see that it's going to present your growth rate data in a different form into the line graph instead of the box plot we had for the entire experiment.